All right, folks. Okay, so let's see. It's gonna post this for tomorrow, so it'll be May 15th. We are talking about, what are we talking about actually? Compound linear inequalities and two variables. Where's my mouse? Hold on. I got too many Desmos windows open. Okay. Linear inequalities and two variables. Gosh, sorry about that, folks. Linear inequalities in two variables. Okay. Let's talk about the do now. Can you find a pair of values that is a solution to this linear equation? So easiest way to do this is to graph it. Y equals 1/2 x plus 4. Y equals 1/2 x plus 4. Graph paper, so we're gonna make a graph. Should be pretty easy to do so. I actually don't want that. Let me get a protractor. All right. So just make a small graph here. It doesn't have to be too crazy big. It's going to be more on the upper half of the graph because this is plus 4 and then it's a positive slope, so it's going up. So something like that for your x and y axes. 1, 2, 3, 4, and we go up 1 over 2, up 1 over 2. We can reverse it a few times. And so we get this right here. So that's what it's going to look like graph-wise. And then if we... Sorry, Macy's going to be upset. I'm going to sneeze again. Oh, so sorry. Can you find a pair of values that is a solution to this linear equation? Oh, look at this. Over 2 and up 1, 2, 3, 4, 5. 2, 5, 0, 4. That's our y-intercept. -2, 3. Tons and tons of solutions. I mean, in fact, there's like an infinite number of solutions, right? So we can find more than one. We can find all of them if we wanted to spend a lot of time writing them out. What can you claim? What can you model? Well, there are an infinite number of solutions because this line goes on forever. Just depends on when you start pinning it down, whether you start defining an x or a y, and then you are able to generate the other value for that. But yeah, there's an infinite number of points on this line. So there are an infinite number of solutions to this if we think about it in those kind of terms. Objectives right here, linear equations in two variables, basically like lines that we graph. And we're going to be talking about inequalities, linear inequalities. So we look at this first one. I quite like doing these on paper. So I'm going to write this down, and then while I'm looking at it, y is less than -2/3 x plus 3. We have studied and practiced. Here's only two variables. What are its solutions? Okay, so it's going to be a line, so I'm just going to graph. Doesn't have to be a huge line. Or it doesn't have to be a huge graph, sorry. So, I don't know, something like that. Okay, this is our x, that's our y. We're going to start at plus 3. We're going to go down 2 and over 3, down 2 and over 3. We'll reverse it to get a few, get an extra point. So I think we can actually do one more there. Oh, now before we do our line, please notice this is less than, not less than or equal to. So when you graph it, it can't be a straight line all the way through. It's got to be a dashed line, okay? Sorry, I got to blow my nose. Oh, Macy, I'm so sorry. Okay, and so we've got our dashed line right here, and then it does say less than, so it's basically just saying that everything below the line, okay? So now we get to just color it a little bit. So we kind of shade in everything below the line on the graph. So you get to do a little coloring. Isn't that fun? So everything below this line is a solution to this equation, or to this inequality, I'm sorry. So for instance, this point right here at -1, 2, that would be a solution, okay? Point right here at 1, -4 would be a solution. Because it's in the shaded part, these are all solutions to this, right? If I take one of these, doesn't really matter which one, and I plug it in here, I get, let's just do this one, I got this -4, so it's going to be -4 is less than -2/3 times the x value of 1 plus 3. I got -4 here. This is -2/3 plus 3. That's going to give us -4 is less than 3 1/3, which is true, right? Now a point right here, for instance, this would be 1, 2, 3, 4, 5, 5, 4. This is not in the shaded part. So let's actually plug this in and see what we get, right? So 5, 4, it would be 4 is less than -2/3 times 5 plus 3. -2/3 times 5 is -10/3 plus 3. We can think of this as 3 1/3, right? So if you subtract this -3 1/3 plus 3, you end up with a -1/3. So it's saying that 4 is less than -1/3, which is not true. So that's why this is not a solution to it, right? So let's just double check our math. With the Desmos graphing calculator, y is less than 1/2 -2/3 x plus 3, and we get the exact same thing. You know, I'm going to make it orange because that's what I got on my paper, right? So it's the exact same thing. Any point over here is a solution. Any point over here is not a solution. Okay. All right. Similar to yesterday, I'm not going to go through all of the problems. I'll put them right here up here if you kind of want to pause it here just to work. But I'll also post this this slideshow in Google Classroom with the answers to it. Maybe I'll put a link to like Desmos with this graph so you can mess around with it. But yeah, I would suggest doing the work on paper and double checking your work with Desmos. But there you go, guys. Thank you.